equals dy by dx equals to, what do we need to do? I'm not going to write it again. But we can do cross multiplication, right? So you have xy minus 3y plus x minus 3 dy equals to xy plus 2y minus x minus 2 dx. So that's the first step. You can do that, right? Separating the fraction by cross multiplication. So the next question is how you separate x from y. That's the main thing. And the only thing you need to do here is to use algebra to separate x from y.
Combine like.
So let's see. I can see there's a y here. You can take this out. And then you end up with x minus 3. And there is plus x minus 3 here. Right? dy. And then I can see there's a y here I can take out. So there's a y and then x plus 2. And there's a negative 1 I can take out from the last two terms. So I get negative x plus 2 dx. Right? But if you look at this bracket here on the left-hand side, there is x minus 3 common, right? We can pull this out from these two terms. Okay? Then we get x minus 3 multiplied by y plus 1. Because I'm taking x minus 3 outside as a common factor, dy. From the other side, I can take x plus 2 as a common factor. So you get x plus 2.
That's clever.
And you end up with y minus 1, right? dx. So now, since I wrote this as a product, then I should be able to separate x from y. And that's the idea. If you want to separate something, it has to be written as a product. Because you should be able to divide now. So we're going to extract x from here because there is a dy. So we're going to keep the y plus 1 and dy. And get rid of x plus minus 3. X minus 3. So you divide by x minus 3 both sides, right? So this is gone. Then you end up with what? With y plus 1 dy equals to what? Equals to x plus 2 y minus 1
Over x.
over x minus 3 dx. But the other side, this side is fine, the left-hand side, right? It has y and dy. But if we look at the other side, we have the dx and we have the x plus 2 and x minus 3, but we still having there y minus 1 we have to get rid of. So how we get rid of y minus 1? You simply divide both sides by y minus 1, right? Y minus 1. So if you divide both sides by y minus 1, then that's gone from the other side. Then this becomes what now? Then the other side becomes y plus 1 over y minus 1 dy. And the right-hand side becomes x plus 2 over x minus 3 dx. So we were able to separate x from y. You can see that in the last equation. Once you do that, then we can go ahead and integrate both sides with respect to y. So it's y plus 1 over y minus 1 dy equals to the integral of x plus 2 over x minus 3 dx. You just need to integrate. So how we integrate now? So we're going to integrate y plus 1 over y minus 1. How we integrate that with respect to y?
I got a question again, but the answer is like, how you get that the y plus 1 again from the...
Yeah, I just get 1 plus 1 y minus 3.
You factor x minus 3. So if you take x minus 3 from here, you get y. If I take x minus 3 here, you get nothing but 1. So you take that out and you end up with y plus 1 by factoring. Same thing here. You factor out x plus 2, they end up with y minus 1. Okay? You divide to separate. So the next question is how we integrate y plus 1 over y minus 1. This is a fraction, right? How we integrate fraction.
Partial fractions.
Especially when the numerator and denominator are the same degree. You can use partial fraction, but here, does it make sense to use it?
No.
Because the denominator is linear. We use partial fraction whenever we can split the denominator into a product of two linear factors. But the denominator is already linear. So there is no point of doing that, or it doesn't make sense to write this as a sum of two fractions.
So
You can do this.
rewrite it?
Whenever the numerator and denominator are the same degree, you can go ahead and divide using long division to reduce the fraction.
Wow.
If they have the same degree, which is the case in both, right? We can use long division to reduce that. So what is y divided by y is 1. 1 times y minus 1 will be y minus 1. And then you subtract. Y minus y is 0. 1 minus minus 1 is 2. So the answer is what? When you divide this by this. So y plus 1 over y minus 1 equals 2. The quotient is 1. And the remainder is 2. So it is 1 plus 2 over y minus 1. So you can reduce it by long division. Okay? Which means if you take these two fractions and combine them, you should end up with this fraction. And that's obvious, you can test that. If you combine this again, the common denominator is y minus 1. And then you need to multiply this by y minus 1. And then add it to 2. Then y minus 1 plus 2 gives you y plus 1, right? And that's obviously the same as this fraction. So use long division, as you learned in the 5th grade. So you take this, divide by this, right? Y plus 1 divided by y minus 1. Long division is what? You take this y, divide by y, so you get 1. Y divided by y is 1, right? So that's, you put in the quotient. Then you take 1 multiplied by the whole factor. So what is 1 times y minus 1? That's y minus 1, and then you subtract. Y minus y is 0. 1 minus minus 1, that's 1 plus 1, which is 2. So this is called remainder, this is the quotient. So which means what? If I take this divided by this, if I take y plus 1 divided by y minus 1, my quotient is 1, and my remainder is 2 divided by the divisor, y minus 1. So that's how we write the long division. Okay, the results from the long division. So that's the idea, is to reduce that and to get it to the sum of these two fractions. Then the goal is what? The goal is to integrate y plus 1 over y minus 1, right? So how we integrate this? But since this is the same as this, then instead of integrating y plus 1 over y minus 1, I should integrate what? I should integrate 1 plus 2 over y minus 1. So this is the same as the integral of 1 plus 2 over y minus 1 dy. But that's not hard to integrate because the integral of 1 is y with respect to y. And the integral of 2 over 2 is a constant, so you end up integrating 1 over y minus 1, which we know this is what? Straightforward integral. We should know this one.
ln.
That's ln y minus 1, right? So the answer becomes 2 ln y minus 1. So that is the left-hand side integral. Okay? What about the right-hand side integral? You're going to do the same thing. Okay? So this is the left-hand side. Left-hand side. Okay? What about the right-hand side? Which is the integral of x plus 2 over x minus 3 dx. So you're going to do the same exact thing because this is similar. So what do we do?
Long division.
Long division. How we divide x plus 2 by x minus 3?
Same way.
You take x, divide by x, you get 1. right? 1 times x minus 3 get x minus 3. Then you subtract. X minus x is 0. 2 minus minus 3, that's
5.
what? Positive 5. So the long division becomes what? X plus 2 over x minus 3 is the same as 1. The quotient is 1 and the remainder is 5. So it's 1 plus the remainder divided by the divisor. So that's the result from the long division. The quotient plus remainder over divisor. So which means instead of integrating this, I should integrate this now, these two fractions. So this integral is identical to the integral of 1 plus 5 over x minus 3 dx, which equals to what? The integral of 1 plus the integral of this, right?
X.
So the integral of 1 is x, plus 5 the integral of 1 over x minus 3 dx, which we know this is similar to this. That's a natural log again. So the answer becomes x plus 5 natural log of x minus 3. So this is the right-hand side. You put them together now. Okay? So now what is the final answer? They go back here, right? So you have two sides, two integrals. We did each one separately. So the left-hand side is this. So it's y plus 2 natural log of y minus 1. Equals to what? Equals to x plus 5 natural log of x minus 3. And don't
Plus
forget
C.
the constant. You have to add it to one side of the equation. So there is no point of putting c here and c, or c1 on this side and c on the other side, because c1 and c2 are constant. At the end you can combine them and call that constant c and put it in one side of the equation.
So
And that's the final answer.
in the case of the initial value, I would have had to solve for C.
Right. If you have an initial value and I give you a condition here, let's say y at 0 equals to 1, then you would plug in x and y there and find c, and go back to the equation and replace c. So then we've done this one, so therefore the rest will be exercise for you. So you can go ahead now and work on them. Okay? So take the time now, sit together.